So hello everyone. So I welcome you all in this new lecture. So in this lecture we are going to discuss the hooks joint. So we'll discuss the construction, working, the application, and the analysis of the hooks joint. So first of all, we'll see the basic construction of hooks joint. So hooks joint is also called as a universal joint, and mainly this hooks joint is useful in the automobiles where we need to transfer the power, or we need to transfer the motion from the gearbox to the differential. Okay, so hooks joint is a joint which will connect the input shaft or driving shaft to with the gearbox and the driven shaft with the differential pinion. Okay, so and this is also useful where you can say the misalignment of two shafts, input and output shafts are present. Okay, so let's see the construction part of it. So this hooks joint, this is the diagram for the hooks joint here. You can say the schematic diagram for the hooks joint. In this diagram, there are two Y-shaped yokes are there. The one is connected with the input shaft and one is connected with the output shaft. One is you can say one Y-shaped yoke is the input shaft and one Y-shaped yoke is the output shaft you have. Okay, and this two Y-shaped yoke is connected by the cross. So this cross may be a circular one. The cross section of this cross can be a circular one, can be a square one, but generally we use the 90-degree right angle cross for transferring the motion from input to output. Okay, so now let's see the analysis part of the hooks joint, how we can calculate the velocities, angular velocities of input and output shaft, how we can compare the angular velocity of output and input shaft. So right now we are going to see the single type of hook joint, single hook joint. So for single hook joint there is only two yokes will be connected. So there is some drawback of single hook joint. There is a drawback of single hook joint is that the input and the output motion, the driving speed and the driven speed is not uniform in the case of single hook joint. So for remedial purpose we can use the double hook joint where the input and output motion will be a uniform. Okay, so for time being we'll study only the single hook joint and we'll find out the ratio of velocity, angular velocities of output link, or you can say driven shaft to the driving shaft. Okay, so let's see the analysis part of this hooks joint first of all. So you have already seen the construction of hooks joint where we were having a two Y-shaped yokes. One is the driving, one was the driven. So same Y-shaped yokes will draw. So let's say we are drawing this Y-shaped yoke from the top side, from the top view we are drawing. So if we draw that Y-shape, the input shaft from the left part from the top view, so this will be a single horizontal line. So this is, let's suppose you have a horizontal line you have. So this horizontal line will give you the top view of driving shaft. Okay. Okay. So this is the top view. Let's say the name of this point is A, name of this point is B. So this is top view and this is the midpoint. So let's say the name of midpoint is O. Okay. So this is the driving yoke. Okay. Similarly, driven yoke is at certain angle. Let's say certain angle is alpha. So certain angle से क्या है आपका driven shaft inclined है. So driven shaft आपने इधर inclined कर लिया. So here is your driven shaft which is inclined at certain angle of alpha. So this angle is given as alpha. Let's say this point name is C and D. Let's say this is C and this is D. So this is CD point here. Now this is the top view you have drawn. So now we'll draw the front view of it. So drawing the front view, we'll project this thing in the down side. So if you project this one here, let's say here I have a front view. Okay, so let's say on this point you are getting your horizontal line. So if it is a input yoke, the front view, if you see it from the front side, this will be the motion of the yoke will be a circular motion. The motion of the input shaft will be a circular motion. So let's Okay, so let's draw a circular line from here. So this is nothing but a circular path of driving shaft, and similarly at the same time the driven shaft is also there. So driven shaft will give you a elliptical motion. So let's say these are the projections for the driven shaft. So if you want to project this one, so if you want to draw this one, so driven shaft will follow an elliptical path for this one. So this path should be a elliptical path. Okay, so we have drawn these lines. These lines will show. These two will show you the path. So this is nothing but A point, and this is nothing but B side, and this will be C point, and this will be D point. So these are the projections, but not this one actually. This point we are calling as C, and this point we are calling as D, because if you see from the front end, the cross part, yes, we have drawn here. Cross connection, that we have drawn. Okay, so now we'll start the analysis part, and we'll rotate our input shaft, that is this A B shaft, by an angle theta. Let's say the input shaft is going to rotate by an angle of theta, and that input shaft angle will be here. Let's suppose after certain time this is rotating by an angle theta. Thus A is coming here somewhere here. So this is, let's say this point is A, one point. So if A will come here, so this B point will come on this side. So this point is called as B, one point, let's suppose. Okay, so after certain time this moves by an angle theta. So this is the angle theta turned by the driving shaft. So if driving shaft is turned by an angle theta, the driven shaft will also turn by an angle theta only. So this is my driven shaft, you can say path, was elliptical path. So driven shaft will rotate in the elliptical path. So this will come on this point, suppose. So this is coming here. This point will be named as C1. So this point is suppose C1 point, and at the same time this D point will also move here. So this point will be called as D1 point, and the angle turned by this angle will be called as theta angle. Okay, but this theta angle is actually the apparent angle, because you are seeing your cross from the front side, and at particular angle alpha this is following the elliptical path, means your yoke is not in its actual length. So this angle theta is the apparent angle. Okay, so to achieve the true angle of this theta angle, you have to project this C point on the true path, that is a circular path. So for this projection, you can project it above. Let's say this point name is N1, this point is N, and you can rotate, you can put your arc here ON, and you can just rotate it here, and this point will be called as N1 dash, suppose. Okay, so once you get this point, you can project this point down again. So once you will intersect it on the circle, and this circle will be always in the horizontal point, this point will be called as C1 dash point. Okay, so here we have done the projection. So this is the projection we have made, C1 dash point. So this should be a horizontal line only. So this point is called as C1 point. Now you can project this C and C1 in this path also. So जैसा आपने ऊपर प्रोजेक्ट किया है, similarly we have projected it down also. So this point was O. So this will be again N1. So this will become N. Let's get them with different color chalk. So this point will be also called as N1 dash. Okay, and if we join these 2 points, this O and this C, so this will give you, this angle will give you the true angle moved by the driven shaft. Okay, so this true angle moved by the driven shaft will be called as angle phi. Okay, so this is all we have done the construction part on the front view and top view. Only to understand how our input shaft and output shaft is going to rotate. So this here the value of alpha, that's angle between the two shafts, the value of alpha is constant, the value of alpha is not changing, and the limit of for this hooks joint, the limit of alpha should be always less than equals to 40 degree, not more than that. So more than 40 degree अगर उसका alignment misalignment रहेगा, so hooks joint properly work नहीं करेगा. So hooks joint, for hooks joint angle should be less than 40 or equals to 40 degree. Okay. So we have rotated our input shaft by an angle theta. उसके according आपको क्या मिला? Input shaft का angle कितना rotate हो रहा है? Theta. And उसके according output shaft का angle कितना rotate हो रहा है? Angle is rotated by phi. Clear है यहाँ तक के? So now we can start calculating the values now. So now you can see here triangles. Now you can see this O point, O triangle, C1 triangle or C1 dash, O, C1 dash and N1 dash triangle. So in triangle we are seeing in triangle O, C1 and N1 dash or O, C1 dash N1. So this triangle we are going to see. So this triangle. So O, C1 and this N1 dash triangle. This triangle we are interested in. If this angle is phi, so alternate angle, this angle will also be phi, because a line is making an angle phi with this vertical line, so same line will make angle phi with this vertical line also. So this angle will also be a phi angle. That is a principle of, you can say, alternate angle. So if this angle is also phi, now can you apply the value of tan phi over there? So I am going to apply tan phi on O, C1 dash and N1 dash on this triangle. So if you apply tan phi angle, so this will become base and this will become perpendicular. So the base upon, so perpendicular upon base. So perpendicular is O, N1 dash upon base is N1 dash and C1 dash. And we know one thing, that this N1 dash C1 dash will be same as this N1 C1. So this is also N1 point. Okay. N1 and C1. So if you measure this one, this is O, N1 dash upon N1 C1 we have. Okay. Similarly, we have one more triangle, that is triangle O, C1 and N1. So OC is making an angle theta. So this O, C1 and N1, this angle will also be angle theta. So if let's say tan of theta, so that will become O, that is perpendicular, O is ON, 1 upon base is this N1 into C. Okay, so this is my tan theta and tan phi. So this is the triangle, nothing but triangle O, C1 and N1 we have used. So we have two equations now, so you can divide this to two equations. So I will get the value of tan theta upon tan phi. This value will become, these two values you have to divide. So this will become ON1 upon N1 C1 multiplied by N1 C1 upon ON1 dash. So I have taken the reciprocal of it. So that 2 will be cancelled out. So the final value will be ON1 upon ON1 dash. So these two values we have. Okay. Now I need to remove these two values also. So for this removal, we will see the front view of it. So here we have also same point, that is ON1, ON1 dash and ON. So these points we have. Okay. So now let's say I need to find out the value of ON1 from here. So the value of ON1, so the value of ON1, this value of ON1 can be, this angle is alpha. Okay, so this value of ON1 can be represented by, can I say this value of ON is nothing but ON cos alpha, बोल सकते हैं कैसा? So this value is ON. Okay, this value is ON and this point is anywhere. So let's remove a bit first half of this. That will be more clear to you. Let's rub this part. So actually these are the points here. So this was point N and you have rotated this point here, and angle between this line is alpha. Okay, and this point was O. So this was the angle alpha. Okay, now I am interested in finding the value of ON1 now. So this point was N1 dash actually. Okay, so we were interested in finding the value of this ON1. So this ON1 is nothing but ON cos alpha. Can I say this ON is cos component of this one, because this is nothing but a right angle triangle. Okay, so this ON1 is nothing but ON cos alpha. And can I say this ON is and ON1 dash is same, because we have rotated this ON to get the ON1 dash. Okay, so this ON will be same as ON1 dash cos alpha. Okay, so ON1 will become ON1 dash cos alpha. So we'll put on the equation. So we'll get tan theta is equals to tan phi. That should be equals to ON value. So ON1 dash cos alpha upon ON1 dash. So this 2 will be cancelled. So final value of tan theta will become, so it's tan phi into cos alpha. So this is the value of these are the values of, you can say, angles. This is the relationship of angles here. So tan theta will be equals to tan phi into cos alpha. Now we'll differentiate this equation and we'll achieve the value of omega 1 and omega 2. So I think so till now it's clear to you. So if you are not clear with the concept, just repeat the video and just see this one first of all, because this value is very important. Based on this value only, we are going to conclude on which point your value of omega 2 and omega 1 will be maximum and minimum. Okay, so based on this relationship, this theta is what? Angle made by the input shaft, phi is angle made by the output shaft, and alpha is what? The angle between both the shafts. Okay, input and output shaft. So if I'll differentiate this equation by t, so what I'll get? So it's d by dt of tan theta, that should be equals to d by dt of tan phi into cos alpha. So alpha is what? Alpha is a constant term, that is constant angle. Particular vehicle के लिए particular time में the alpha value will be always constant. So this cos alpha is always constant, and this theta is going to rotate, and based on theta the value of phi will also change. So let's differentiate it now. So I know this, if I differentiate this one tan theta, so this will become sec square theta, and this theta should also be differentiated. So d theta by dt was what? The rate of change of angular displacement for input shaft, so that will be called as omega 1. So d theta by dt is called as omega 1. This is general differentiation. We have done it lot of the times. Okay. So d by dt of tan phi now, because cos alpha is constant term. So let's take cos alpha out. So cos alpha is constant term. Let's take it out. And if we differentiate this tan phi, so this will become sec square phi, and d phi by dt, then again it will become omega. Okay. Now I have value of omega 1 and omega 2. So we are interested in finding the ratio of omega 2 by omega 1. So let's do this one. Omega 2 by omega 1. So when we will do this one, so this will become sec square theta, and this will become cos alpha. And this sec square phi can be converted. This was sec square phi. No, sec square phi is correct. So sec square phi we can solve a bit. If I want to solve this, if I want to find out this value of sec square phi, this can be a 1 plus tan square phi. Okay, because we don't know the value of sec square phi, but we know the value of tan square phi from equation number 1. So if you solve this equation of 1 a bit, so that will become tan phi, that is tan theta upon cos alpha. Okay, so from this 10 you can put down the value here. So let's solve a bit. So this will become sec square theta upon cos alpha to 1 plus. So this tan phi should be tan theta upon cos alpha. So this will be tan square theta upon cos square alpha. So tan को भी अपन और convert कर लेते हैं. So that directly I am writing. So if you do tan square, so this will become tan square or cos square. This because I need to put the value of tan square phi. That's why I have squared on both sides. So this will become tan square theta upon cos square alpha. And इस tan square theta को आप ऐसा भी लिख सकते हैं क्या? That is sin square theta into cos square theta. Sorry, sin square theta upon cos square theta into cos square alpha. Okay, so we are expanding this equation a bit. थोड़ा और expand करके लिखिए अपन ने इसको. So directly I am writing this value here. So this is now sin square theta upon cos square theta into cos square alpha. Now we will find out the LCM of it. So if you find out the LCM of it, so this will become, the denominator part will become cos square theta into cos square alpha, and this cos alpha and this cos square alpha का एक part cancel out होगा, यानी पूरा part क्या जाएगा, आपको ऊपर जाएगा, and ये sec square theta into cos square theta will become 1. तो थोड़ा इसको finally आप solve करेंगे, so you will get cos alpha upon, this is cancelled out, so यहाँ पे क्या बचेगा सिर्फ आपके पास, we will have cos square theta multiplied by cos square alpha. So I will put cos square alpha as 1 minus sin square alpha plus sin square theta. थोड़ा सा एक स्टेप रिड्यूस करके सॉल्व किया अपन ने, जस्ट टू सेव स्पेस, एक्चुअली स्पेस एंड टाइम आल्सो. ओके, सो ये अगर थोड़ा सॉल्व और करेंगे तो क्या बचेगा आपके पास, दिस cos square theta will be multiplied with the 1 and this will become cos square theta plus sin square theta. So cos square plus sin square theta is 1 and this cos square theta will be multiplied with this sin square alpha. The final value of omega 2 by omega 1, so you can say final value of omega 2 will be equals to omega 1 multiplied by cos alpha upon, this is become 1 minus cos square theta, omega 1 multiplied by cos alpha upon 1 minus cos square theta multiplied by sin square alpha. So this differentiation you have to do. Okay, so this omega is also not, this omega 1 is also, this omega 1 is constant this time, so you can take this omega 1 out and d theta by dt is again omega square. So you can differentiate it, and if you differentiate it, so I am not going to differentiate the entire part, so if you differentiate it, the final expression alpha 2 will be minus of omega 1 sin square alpha cos alpha and sin of, now it's 2 theta, no, not square of, sin 2 theta upon, so it's 1 minus cos square theta sin square alpha and the square of the entire value. So this is nothing but the value of, if you differentiate this one, this is differentiation by parts. So first part divided by second part, d by dx of first part minus integration of this huge derivation you have to do, it's a 2-page derivation you have to do, and after that you will come to this point. So this is the final value of expression directly, and I am not going to derive it now. Okay, so this is the value of alpha 2 we have. Okay, so this alpha 2 is nothing but angular acceleration of output shaft. Okay, now one more thing they might be interested in finding out, that is called as fluctuation of speed. That is called as fluctuation of speed. So omega fluctuation of speed will be always equals to omega max minus omega minimum. This value you are supposed to calculate. Omega fluctuation of speed, omega f we can represent the fluctuation of speed. So that omega max minus omega minimum, and you know the omega max, omega 2 maximum obviously, and omega 2 max is what? Omega 1 upon cos alpha and omega into. So you can take omega 1 as constant out. So 1 minus 1 upon cos alpha minus cos alpha. So if you want, you can solve this expression a bit. थोड़ा सा solve भी कर सकते चाहेंगे तो. So this will become cos alpha 1 minus cos alpha, and you can solve it. Okay. So this is nothing but the called as fluctuation of speed. Okay. So these are the terms which are important for calculating the Hooke's joint. Now based on these terms, these all terms, we'll draw. We have found out the maximum velocity, minimum velocity, and same velocity. We'll draw a polar diagram for velocity and acceleration. This polar diagram is very important because in every numericals you have to draw your polar diagram for calculations. Okay. So let's draw the polar diagram first of all. So let's see first of all how we can draw the polar diagram. Okay, so let's see first of all three things. First of all, we have one ratio, that is omega 2 maximum is nothing but omega 1 upon cos alpha. Second one is omega 2 minimum, that is equals to omega 1 into cos alpha, and third is what? For the same omega 2 and omega 1. So omega 2 will be same as omega 1. So for this condition, your tan theta was equals to plus minus of root over of cos alpha. Okay. So now we can see for this one, for omega 2 maximum, we were having the angle theta as 0 degree, 180 degree, and so on. This 180 degree angles will be there. And for this one, we were having theta as 90 degree and 270 degree, and so on. Because on 90 degree to 70 degree, the value of theta is equals to 0. Okay. Now for this value, for this, the value of theta will depend on the value of alpha. कि अल्फा का क्या वैल्यू आता है उसके ऊपर आपका ये थीटा का वैल्यू डिसाइड करेगा. बट नाउ देयर आर टू वैल्यूज ऑन विच मैक्सिमम यू विल गेट, टू वैल्यूज ऑन विच मिनिमम यू विल गेट. नाउ द क्वेश्चन इज हाउ मेनी वैल्यूज यू विल गेट ऑफ थीटा फ्रॉम हियर. Okay, so let's see this one first of all. First of all, there is a plus and minus sign. So for each value of alpha, there will be two values of theta. Yes or no? Two values of tan theta you can see. Yes or no? Yes. So for each value, let's say alpha is given as 20 degree or 30 degree. So for each value of cos 30 degree, there will be plus 30 degree and there will be minus 30 degree answer for theta value. Plus and minus, two values of theta is there, and we know for each value of theta there will be two values of tan theta is also possible. Okay, so for each value of alpha there is two values of theta, and for each value of theta there is two possible values of tan theta. So total there will be four values of theta on which your omega 2 will be same as omega 1. So that four values again depend on value of alpha only, कि alpha का value किसके हिसाब से change है. Okay, so if you draw your polar diagram now, so for polar diagram you will have these two axes you have. Okay, so one will be your major axis, one will be your minor axis. So if you draw this polar diagram for the input shaft, okay, so here we are going to draw the polar diagram. Okay, the polar diagram we are going to draw here. So this diagram we are going to draw based on angles only. So here we have started the 0 degree angle, here is your 90 degree, here is 180 degree, and this is again 270 degree, and this is again 360 degree angle. Okay, so for input shaft omega 1 we will draw. So for input shaft the omega 1 value is always constant. So if the value of omega 1 is always constant, so this will give you a circular diagram. So this omega 1 will be always constant. So this is nothing but the omega 1 direction. So on this line, this omega 1 will be always a circular path. So with respect to this omega 1, so from 0 to this distance will be called as omega 1. So this is also omega 1, this is also omega 1. It's a circle. So from center O, each and every point of polar diagram will show the omega 1 value. Now we will show the omega 2 part. So omega 2 maximum किसको मिला था आपको 0 डिग्री एंड 180 degree पे, so 0 degree यहाँ रहा and 180 degree यहाँ रहा. Let's say on this point you are going to have the value of omega 2 and this value is nothing but omega 1 upon cos alpha. Similarly, and both value will be same, no? Remember, so from O to this point and O to this point value will be same. So if this is the point, so let's say here this is the point where I am going to have a omega 2 value. So omega 2 is this point. Okay. Similarly, minimum points. So minimum is 90 and 270 angle. So from 90, this is obviously minimum is what it will be less than omega 1 because you have to multiply with cos alpha, and cos alpha will be obviously less than 1. So this is less than omega 1. So this is omega 2 minimum you have, and this value will be omega 1 multiplied by cos alpha, and this is omega 2 maximum, no? Remember. Okay. Similarly, same on same distance you will get here also omega 2 minimum value. Okay. So if you draw this one, if you draw this diagram, कैसा होगा? This is called as your OW2. This distance will be called as your semi major axis, and this will be called as semi minor axis. So name of this circle, so this will join this one. So this point, this diagram will be called as your polar diagram. So this elliptical path is nothing but the for the output shaft. This elliptical will be for the output shaft. Okay. So there are different names of all the points. So these names will be 1, 2. These are the 1 and 2 points. So the maximum and minimum point. This point is called as point 3. And this point will be called as point 4. That is minimum points. And this point, this is called as 5, 6, and this will be called as 7, and this is called as 8. Okay. So this 1 and 2 will show you the maximum point, 3 and 4 will show you the minimum point, and this 5, 6, 7, 8 will be shown as omega 2 as same as omega. Okay. So this was all about your polar diagram and Hooke's joint. Now in next lecture we'll solve some numericals based on this one. So in each and every numerical you have to draw your polar diagram. You have to find out the value of omega 2, omega 1 as well as the omega 2 as same as omega theta for this 5, 6 and 7. Okay. So the name of all points are very important because in online examination, in MCQ based examination, they can ask you the values of points also. So what is the value of omega 2 at point 1? What is the value of omega 2 at point 3 or 4 or 2? Okay. So this type of question may also be asked in the examination. Okay. So thank you very much.